Problem 118. To find the length of arc of a cycloid x is equal to a into theta minus sine theta, y is equal to a into 1 minus cos theta. So you have to remember it that these two values of x and y which are given in parametric form, they give us the following figure in the form of cycloid, and you have to find out the length of simply one arc. These are various arcs formed by the cycloid, and one of the arcs when considered will give you the length of arc. So you know the formula for finding the length of arc when the equations are given in parametric form. The formula is given by dx over d theta plus dy over d theta whole square, and the limiting value of integration from lower to upper limit. So here x is given by x is equal to a into theta minus sin theta, dx over d theta is equal to a into 1 minus cos theta, and dy over d theta is equal to a into cos theta. You simply plug these values by making some simplification or trigonometric manipulations and put these values in this equation. Because here the cycloid is symmetrical about the line through the point when theta is equal to pi and perpendicular to x-axis, that is this one. So when I take the value of theta from 0 to pi, it means half of the arc length is obtained. Another half will be computed by just multiplying the previous half by 2. So you simply plug these two values and then make some simplification. After integrating, this is done for you. Integration has been done in this solution totally for you people. So you can take this solution for your assistance, otherwise you have to perform yourself the calculations. So ultimately it will give you the 8 A units, the length of arc. Similar question is also given for your practice. In this question you have to find the length of arc of cycloid x is equal to a into theta minus sin theta, y is equal to a into 1 plus cos theta with variation theta from 0 to pi. Next, to find the length of one arc of a given curve. X is equal to a into 3 sin theta minus sin cube theta, y is equal to a cos cube theta from 0, 0 to any point. So students, here I am asking you to find the length of curve from origin to any other point. So in this case, you will apply the same formula again for finding the length of arc from lower to upper limit, that is dx over d theta square plus dy over d theta square, and then taking the limits from 0 to theta. I am here taking the value of theta from 0 to theta because I have given you that you take the value of parameter from origin to any point. So upper limit will be fixed at theta. Then you simply take some assistance from here again to find out the integration values. These are well familiar to you earlier, and therefore after finding the integrating values you will get the answer 3a over theta, 3a over 2 into theta plus sine theta cos theta. So this is how we find the length of arc. After finding the length of arc, which is covered under the concept of rectification, we shall now start the next topic, that is the quadrature. Quadrature is nothing but the area of curves in the plane. Earlier we were finding the length of arc of the curve. Now we will find the area of curves in the plane. Again, I will give you some curve or line, and then I will ask you to find out the area under that curve. So for the simplicity, I have taken first example problem in the form of problem number 121. In this case, you have to find the area bounded by the lines y equal to x and x equal to -1 and x equal to 1. So y equal to x is the graph of this line like this one, and the value of x is varying from -1 to 1. So you simply find out the area from one side, that is 0 to 1, under the curve y equal to x, then we multiplied it. So 0 to 1 y dx, this is the formula for finding the length of for finding the area of the region under the given arc or curve. So upon integrating and putting the values of upper and lower limit integral limiting values, you will get the answer 1 square units. Again, next question is find the area of the circle of radius r. In this case also, the circle is symmetrical about x-axis and y-axis, and it is segmented into 4 quadrants. I will find the area of one quadrant from 0 to a 0 to r, because radius is given as r, and then multiply that by 4. So area of circle will be 4 times 0 to r into r square minus x square. Where from I have taken this r square minus x square square root, because you know that the equation of circle is x square plus y square equal to r square, this one. And from here you find the value of y, that will be square root r square minus x square. And area of circle is 4 times 0 to r y dx, and y is taken from here, that is r square minus x square. Now you apply the formula of a square minus x square root, that is x by 2 into a square minus x square over 2 plus r square over 2 sin inverse x over r, and then 0 to r. When you plug the value of lower and upper limit and subtract, you will get pi r square. This is the formula for area of circle. Now in this question, number 123, find the area bounded by the parabola y equal to 2x minus x square and x-axis. So y is equal to 2x minus x square. After completing the square, I will get x minus 1 whole square is equal to minus 1 into y minus x. It means this is the parabola whose vertex is 1, 1. That is this one and this one. So turning point will be this point. Now I am asking you to find the area under this parabola and x-axis. This is the x-axis, and x-axis will give you the value of limits, that is origin 0, 0 and 2, 0. How I have obtained this 2, 0? In this case, this is the point on x-axis, so y will be 0. You simply put y equal to 0 over here. You will get two values of x, that is 0 and 2. And these will constitute the limiting value. So 0 to 2 by dx. So y is 2x minus x square. Integration is simple. You simply integrate and get the answer 4 by 3 square units. Next is find the area between the curves y equal to sin x and x-axis from x equal to 0 to x equal to 2 pi. So the graph for sin x is shown in figure, and the value of x is varying from 0 to 2 pi. So there are two regions of it to find the area under the curve and the x-axis. So I simply take the modulus value of sin x and vary the value of x from 0 to 2 pi, then integrate it under two regions. When 0 to pi, the value of x is taken, the modulus value of x sin x will be sin x only. But when I vary it from 5 to 2 pi, that is In third and fourth quadrant, modulus of sin x will give me minus sin x. And then integrate these two, sin x and sin x. Again, the integration of sin x is minus cos x. Now cos of pi is minus 1 into minus 1 plus 1, or plus 1 is 2. And from here you will again get 2. So 2 and 2 will give you 4 square units, the area of a region between the curve and the x-axis. Next, find the area bounded by the curves y is equal to square root x and y is equal to x minus 2. Now look carefully. Y is equal to square root x gives you y square is equal to x, and from here this is y equal to x minus 2. So this is y equal to x minus 2 is the straight line, and y square is equal to x is a parabola. So in the pictorial representation you will obtain this region where you are finding the area of the region. So first you find the value of x or y, which give you the limits for integration. For that you will take the help of these two equations. You substitute the value of y equal to x minus 2 here, and then obtain the equation x square minus 5x plus 4 equal to 0. So here the values of x is 1 and 4, and when x is 1, y will be minus 1 from here, and when x is equal to 4, y will be 2. So these are two intersection points, somewhere here and here. So the value of x is 0 to 4, and square root x, this is the upper region, upper arc, and this is the lower arc, and area between these two will be given by 0 to 4 square root x minus 2, and then integrate it, you will get the answer 16 by 3 square units. So similarly I have solved some more questions for you. Find the area of the curve for x is equal to a cos cube t and y is equal to a sin cube t. And these areas are solved in this lecture. You can see these questions. These are very easy, and you can take the help of solution to understand this concept. So these are few of the problems which have been solved for you people. So kindly go through these solutions and obtain the area of the region under the given arc. Thank you.